Hi everyone, welcome back to my video about programming in Java. This is the last video for a course about introduction to Java programming. And if you have not watched the part 1 of strings and characters in Java before, please watch it before watching this video. This is the second part about strings and characters in Java. In the first part of strings and characters in Java, I had covered basics about class string and some methods of class string. In this video, I will cover more string methods, for example, those that allows you to compare strings and concatenate string and locate substrings, etc. And I will also cover class character and class string builder. You will learn the difference between class string and class string builder, and when to choose class string and when to choose class string builder. Let's first start with comparing strings. In many applications, we may need to compare strings. For example, if you sort a list of students' names where each student's name is a string, then the sorting will need to compare two string objects. When the computer compares strings, it compares the Unicodes of the characters in the strings. This is known as lexicographical comparison. So lexicographical comparison just means to compare the Unicodes of the characters in the strings. The class string in Java provides many methods for comparing strings. And these methods are convenient for you to use when your program needs to perform some string comparison. So the first two methods are equals and equals ignore case. These two methods compare two entire strings for equality. The method region matches compares portions of two strings also for equality. The method compare to compares two entire strings for relationality. So it can tell whether the string is larger or smaller than the other string. And two other methods, namely starts with and ends with, determine whether strings start with or end with a particular set of characters. This program, named stringcompare.java, demonstrates using string methods and using the equality operator to compare string objects for equality and relationality. In the first part of the program, it creates four string objects S1, S2, S3, and S4. String object S1 was created from the string little hello. String S2 is a reference to the string little goodbye. S3 is a reference to the string little happy birthday with the uppercase H and uppercase B for each word initial. S4 is a reference to the string little happy birthday with all lowercase letters. The program displays the value of each of the four strings S1, S2, S3, and S4 before performing any comparison. The first comparison made in the program is between string S1 and the string little hello by calling the string method equals on the object S1 with the string little hello as the argument. The method equals returns a Boolean value. If this call to method equals returns true, the program displays the message that s1 equals hello. Otherwise, it displays the message that s1 does not equal hello. In the second part of the string compare.java program, it also uses the equality operator denoted by the two equal signs to compare the string objects s1 and the string little hello for equality. The equality operator also returns a Boolean value. If this equality operator returns true, the program displays the message that s1 is the same object as hello. Otherwise, it displays the message that s1 is not the same object as hello. Next, the program calls the method equals ignores case on the string object s3, passing the string object s4 as the argument. This method call compares strings s3 and s4 for equality with case ignored. In general, the string method equals ignore case ignores the case in its string when it performs the comparison. So it works like the equals method, except that it ignores whether the letters in its strings are uppercase or lowercase when performing the comparison. So in this example, the call to equals ignore case will return true because the content of S3 and S4 only differ by the cases of the two initial letters in the string happy birthday. Then the program makes several calls to the string method compare2 to compare between S1 and S2 and between S3 and S4. Note that method calls S1.compare to S2 returns an integer value instead of a Boolean value. It returns 0 if string S1 and S2 are equal in terms of lexicographical comparison. It returns a negative number if a string S1 is less than a string S2 in the lexicographical order. Otherwise, it returns a positive number. In the last part of the string compare.java program, it calls the string method region matches to compare portions of string S3 and S4. The first call is on string object S3 with 4 arguments 0, S4, 0, 5. The first argument 0 indicates that the portion of string S3 to be compared starts at index 0. The second argument S4 means that a portion of S4 will be compared to a portion of S3. The third argument 0 indicates that the portion of S4 to be compared starts at index 0. And the last argument indicates the number of characters in each portion to be compared. So this call to the method region matches compares the first 5 characters of S3 and S4. The second call to the method region matches uses the 5-argument version, whereas the first argument is a Boolean value indicating whether the case is ignored or not. And the remaining arguments are the same as the arguments in the 4-argument version. When the first argument in the 5-argument version is true, as in this example, then the case is ignored. So this call to the method region matches also compares the first 5 characters of S3 and S4, both with case ignored. Here is the output of the string compare.java program. The first 4 lines of text in the output show the values of the 4 string objects S1, S2, S3, and S4. The next 3 non-empty lines show the result of comparison for equality. The line S1 equals hello was displayed because the call S1 dot equals hello returns true. The following line was displayed because the comparison using the equal operator between S1 and the string little hello is false. So here you see that even though S1 and the string little hello have the same content, the equality operator equal between them still returns false, which means that they are not the same object. The output line starting with happy birthday was displayed because of the call S3 dot equals ignore case of S4 returns true. The next 5 lines of output show the results of calling the compare2 method. The result of S1 dot compare2 of S2 is 1, which means that S1 is larger than S2 in the lexicographical order. Okay? So note that for the ASCII character or for English characters, the lexicographical order is the same as the alphabetical order. Okay? So when S1 and S2 are switched in the call to the method compare2, like this, the result is a negative number, and here it shows -1. Similarly, S4 dot compare2 S3 is a positive number, meaning S3 is larger than meaning S4 is larger than S3 in the lexicographical order. This is because the lowercase h is larger than the uppercase h in terms of Unicode or ASCII code. And S3 dot compare to S4 is a negative number, which is -32 in this output. Note that here the value 1 or 32 doesn't matter. What matters is that they are both positive numbers. The call S1 dot compare to S1 returns 0, which means that S1 and S1 have the same content. The last 2 lines in the output show the result of comparing portions of S3 and S4. The portions being compared consist of the first 5 characters in each string. Those correspond to the word happy with uppercase H in S3 and the word happy with all lowercase in S4. The method region matches returns false when comparing those 2 words and return true when comparing those 2 words with case ignored. As shown in the string compare.java program, the string method equals and the equality operator equal do not yield the same result when comparing objects for equality. Method equals compares the content of the objects and returns true if the contents of the two objects are equal. For example, the call s1.equals hello in the string compare program returns true because string object s1 and the string literal hello have the same content, which is the sequence of characters forming the word hello. In contrast, the equality operator equal between two objects compares the references to the objects and returns true if both references refer to the same object in the memory. When two separate objects are compared using the equal operator, the result will be false even if they contain the same values. That's why applying the equal operator between s1 and the string literal hello in the string compare program results in the false value because here s1 refers to a new string object that is separate from the string object representing the string literal hello. Note that Java treats all string literal objects with the same content as one string object to which there are many references. There can be many references. So if you declare s1 and assign it to the string literal hello, then applying the equality operator between s1 and the string literal hello will result in the true value because here s1 refers to the same string object in memory that represent the string literal hello. The bottom line is that comparing strings using the equal operator can lead to logic errors because the equal operator compares the references to determine whether they refer to the same object, not whether two objects have the same content. When comparing objects to determine whether they have the same content, use the method equals. Here's another example that serves as a practice or exercise for you to practice with comparing strings for equality. In this exercise, I give you the following declarations for the variables first name and last name as a string, and also assume that first name and last name store a person's first name and last name respectively. So we assume that we already have a code that take care of all of these things. And so now your job is to write a code that prints out the text, the 46th president of the USA. If the first name equals Joe and last name equals Biden. To compare portions of strings for equality, we can use the region matches method of the string class as shown in the string compare program. This method is overloaded with two versions. One version takes 4 arguments and one version takes 5 arguments. In the 4-argument version, the first argument is the starting index in the string that involves the method. For example, in this call to the region matches, the string that involves the method is the object S3. And the second argument is a comparison string. So in this example, that is the string S4. And the third argument is the starting index in the comparison string. So that is the starting index in the string S4 in this example. And the fourth argument in the four-argument version is the number of characters to compare. In the five-argument version of the method region matches, the first argument specifies whether the case is ignored or not. If the first argument is true, the method ignores the case when comparing strings. The remaining arguments are the same as the arguments in the four-argument version of the region matches method. So in particular, the second argument in the five-argument version is the same as the first argument in the four-argument version, and so on. Here are more examples about using the region matches method of the string class. These examples are also an exercise for you to practice with the region matches method. Okay? In these examples, we assume that the string variable s has been declared and graded from the string little welcome exclamation point. So your job is to tell the value returned by each of the following method calls to the region matches method on the string s. And again, I will give you 10 seconds to figure out your answer before you come back to look at the correct answer here. If you need more than 10 seconds, you can pause the video and figure out your answer, write out your answer, and then come back. Okay, so let's start the timer. Okay, so 10 seconds have passed. So now it's time to look at the correct answer. For the first call to region matches, it compares two characters from the string s starting from index 1. So that is the little e, okay, and little l. With the string element, so with two characters from the string element starting from index 0. So those two characters are also little e and little l. So the answer should be true, okay, because they match each other. The second call is almost the same as the first one. The difference is only in the number of characters in each string to be compared. So here we will compare 3 characters instead of 2. So here it compares 3 characters ELC, okay, from the string welcome to the 3 characters ELE, because it starts from index 0 from the string element. So of course these two portions of strings do not match each other, so therefore the result should be false. Okay? And for the third one, it compares also 2 characters from the string s starting from index 5. So this is index 0, 1, 2, 3, 4, 5. So the characters in the string S with index 5 is the little m, and it compares two characters. So it compares the m and the e from string S with two characters starting from index 3, which is also m and e, okay, from the string element. But here this one is also a little m. So both portion of strings match each other, so therefore the answer is true. Alright, so for the last one is a 5-argument version of the region matches method, where the first argument is true. So that means that the case will be ignored. And here it also compares two characters from each string. And the two characters in the string S to be compared start from index 5. So it's also little m and little e. And the two characters from the comparison string starts from 0, from index 0. So it's me. Okay. And so here this one is capital M, this one is little m. However, because the case is ignored, so the result is still true. That's it. Two other methods of the string class, namely starts with and ends with, also compare strings. This program is an example showing how to use these two methods. In the first part of the program, it first declares and creates an array named strings consisting of 4 strings. The 4 elements in the array strings are initialized to the 4-string literal: started, starting, ended, and ending. Then the program has an enhanced for loop that goes through each element in the array strings and calls the starts with method on each element with the string literal st as the argument. This method call returns true if the string content starts with st. Next, the program has another enhanced for loop similar to the first one, except that the call to method starts with takes 2 arguments instead of 1. The first argument is the string literal art, art, and the second argument is number 2. This method call only compares the content of the invoking string object starting from index 2 with the first argument, which is the string art. So it returns true if the invoking string object starts with art or art at index 2. In the second part of the program, it has another enhanced for loops that also goes through the array strings. And for each element of the array string, it calls the ends with method, passing the string literal ed as an argument. So here this method calls returns true if the string object has the content endings with ed. Right? And so here is the output of the program. So it confirms that the string start with the st, and the starting also starts with st. So when we call the string with the content started, when we call the starts with method on the string with the content started, and with the argument st, it returns true. Okay, and so here is the result of the second for loop that calls the starts with method with the arguments odd and 2. Okay? And this is the outcome of the third, which is also the last for loop here, uh, which calls the method ends with. Okay, so it's return true for the two elements in the array strings. Okay, so now we will discuss the string methods for locating characters and substrings in a string object. The string methods, namely index of and last index of, will search for a specific character or substring in a string object. The method index of locates the first occurrence of a character in a string. It returns the index of the characters in the string that it found. And if it doesn't find the character, it returns -1. The method last index of locates the last occurrence of a character in a string. So it works similarly to the method index of, except that it searches from the end of the string instead of from the beginning of the string. This program shows several examples of using string methods index of and last index of. In the first part of this program, it declares a string variable named letters and initialize it to the string little, which is the concatenation of two identical sequences of 13 lowercase letters from lowercase a to lowercase m. So each letter appears twice at 13 positions apart in the letters string. Then it calls the method index of on the string object letters 3 times and displays the result of the calls. The first call passes character little c as the only argument. So it returns the index of the first occurrence of c in the string letters. That index is 2 as shown in the output. The second call uses the 2-argument version of the method index of. It passes the character little a as the first argument and number 1 as the second argument. So this method call returns the first occurrence of letter a from index 1 of the string letters. That index is 13 as shown in the output. The third call uses the 1-argument version, passing the $sign character as the argument. There's no $sign character in the string letters, so this call to method index of returns -1. Next, the program calls the method last index of on the string object letters 3 times. The first one searches for character little c from the end of the string letters. So it returns index 15, which is the index of the last character little c in the string letters. The second one uses the two-argument version, passing character little a as the first argument and number 25 as the second argument. The second argument indicates the index from which the method starts searching backward. Since the last index in the string letters is also 25, this call returns the last index of character little a in string letters, which is 13. So it shows 13 in the output here. The third call searches for a character not in the string letters. So it returns -1 as in the third index of method call. In the second part of the program, it calls method index of 3 times and calls method last index of 3 times also to search for a substring instead of a single character in the string letters. Here is the line of code from the first part of the program that initialized the string letters. The first two calls of method index of and the first two calls of methods last index of in this part of the program search for substring def in the string letters. The call to index of with one argument returns the index of the first occurrence of the substring def, which is at index 3 as shown in the output. The call to index of with number 7 as the second argument returns index 16, which is the first occurrence of substring def from index 7. The first two calls to the method last index of search for substring def backward, and both returns index 16, which is the last occurrence of the substring def in the string letters. The last call to index of and the last call to last index of in this part of the program search for substring hello, which doesn't appear in the string letters, so both calls returns -1. Each method index of and last index of has 4 versions, with the signatures shown in the following table. It has 2 versions taking 1 argument and 2 versions taking 2 arguments. The first argument in any version specifies the character or substring to search for. Note that the argument specifying a character can be any integer that represents a Unicode, so it is of type int instead of type char. Of course, you can pass an argument of type char, which can be converted into type int before it passed to the method. The second argument in the 2-argument versions specifies the index from which the search starts. The next string methods we are learning are those for extracting substrings from a string. Class string provides 2 substrings methods to enable a new string object to be created by copying part of an existing string object. Each method returns a new string object that is a substring of the invoking string. One method takes one integer argument and one method takes two int arguments. The first argument in each method specifies the starting index in the invoking string from which the characters are to be copied. The second argument in the two-argument version specifies the index one beyond the last character to copy. For example, suppose that the string S is initialized to the string little I love Java with a space between each word here, and also there's a period at the end. Then the method called s.substring of 2, so 2 in parentheses, and 2 is the argument, returns return a string that is copied from index 2 of the string S. So the returned string has the content love Java. The method called s.substring of 2, 5, so it has two arguments, 2 and 5, returns a string that is copied from index 2 to index 4 of string S, because 4 equals 5 minus 1. So the returned string is LOV because these are the characters from index 2 to index 4 of string S. The next thing about processing strings we are learning is string concatenation. String concatenation allows you to assemble string objects into larger strings. One way to concatenate strings is by using the operators plus or plus equal. When both operands of the plus operator are string objects, the operator plus creates a new string object in which the right operand string is placed at the end of the left operand string. For example, when you place the plus operator between string little hello and string little word, it returns a new string object with the content hello word. Note that it is a syntax error to break a string little across lines. For example, if you have a println statement like this, where the two double quotes enclosing the string argument are on different lines, then it's a syntax error. If the string little is too long, you can split it into several smaller strings and use concatenation to form the desired string. When only one operand of the plus operator is a string, then the other operand is converted to a string, and then the two strings are concatenated. Note that every primitive value and object in Java can be represented as a string. In particular, a Boolean value can be converted to string true or string false. When an object is converted to a string, the object's toString method is implicitly called to obtain the string representation of the object. Now consider an example of applying the plus operator with one string operand. Suppose a variable y is declared as an int variable and initialized to value 5. Then the expression y plus the string is the value of y evaluates to the string 5 is the value of y. If you assign this expression to a string variable s, then s has the content which is the string 5 is the value of y. As another example, consider this expression in the argument of the println method. This expression has a 2 plus operator, but the plus operator between y and 2 in parentheses is the regular addition, not string concatenation, because both operands of this plus operator are integers. This plus operator between y and 2 in parentheses is evaluated first, and the result is the number 7 because y has value 5 and 5 plus 2 is 7. Then the first operator in this expression is evaluated, and this plus operator is a string concatenation because its right operand is a string. Its left operand is number 7, which is converted to a string with one character 7. So the result is the string y plus 2 equals 7. And when the println print out that string, so it displays y plus 2 equals 7. Confusing the plus operator used for string concatenation with the plus operator used for addition can lead to strange results. For example, consider the expression starting with the string y plus 2 equal, then plus y plus 2, as in the previous example, but without the parentheses around y plus 2 of the second plus operator. If the integer variable y has value 5, this expression results in the string y plus 2 equal 52, not the string y plus 2 equals 7 as in the previous example. To explain this strange result, recall that the plus operator associates from left to right. This means that in an expression with two plus operators without parentheses, the leftmost plus operator is evaluated first. So in this expression, first the value of y is concatenated to the string y plus 2 equal, resulting in the string y plus 2 equal 5. Then the value 2 is concatenated to the new larger string y plus 2 equal 5 to form the string y plus 2 equal 52. Here, both plus operators are string concatenation because the left operand of each operator is a string. If the second plus operator is intended for addition, then you need to put a parenthesis as in the previous example. Another way to concate strings, which is less confusing, is to use the string method concate. This method concatenates two string objects similar to using the plus operator and returns a string object obtaining the characters from both original strings. For example, suppose string S1 has the content hello and string S2 has a content there as in this declaration. Then the method called S1.concate of S2 returns a new string object that has the content hello there. Note that the original strings to which S1 and S2 refer are not modified. You can test this by displaying the value of string S1 after calling a method concat on S1 and see that the content of S1 is still the same as its content before concatenation. Here is an example that you can do to practice with the substring method and string concatenation. So in this exercise or example, assume that the string object named phone number has been declared and contains a string of 10 digits such as 542, 520, 1230, which represents a phone number with area code. This is a phone number in the United States. And you just need to write a Java code fragment to extract the area code, which is the first three digits, and then the next first three digits after the area code, and the last four digits of the phone number, and then display the given phone number in this form, where the area code is put between open parentheses and close parentheses, followed by a space, and then three digits after the area code and a minus sign, and then the last four digits of the phone number. There are many other miscellaneous string methods that are useful to process strings. Let's go over some of them. Method replace returns a new string object in which every occurrence of the first char argument is replaced with the second argument. An overloaded version of the method replace enables you to replace substrings rather than individual characters. Method uppercase generates a new string with uppercase letters. Similarly, method toLowercase returns a new string object with lowercase letters. Method trim generates a new string object that removes all white space characters that appear at the beginning or the end of the invoking string on which the trim method operates. Method toCharArray converts the string object into a char array. It creates a new character array containing copies of the characters in the invoking string. This program shows examples of using the miscellaneous string methods that I have listed in the previous slide. In this program, first, it declares and initialized three string variables S1, S2, and S3. S1 is initialized to the string little hello. S2 is initialized to the string goodbye, all in uppercase letter, and S3 is initialized to the string spaces with a few spaces before the word spaces and also after the word spaces. Then it also displays the values of string S1, S2, and S3. And then it calls the method replace on the string S1, passing two arguments. The first one is the little l characters, and the second argument is the capital L characters. So this method will replace all occurrence of the little l character in the string S1 with the capital L. And then it also calls the method toUppercase on the string object S1, and also call the two lowercase method on the string object S2. And then it also calls the trim method on the string object S3. So this call will remove the spaces before and after the word spaces. The second part of the program is to test the two char array methods. It calls the two char array method on the string object S1 and assigns the result to the variable char array, which is an array of time char. And then it uses an enhanced for loop to print out every character in the char array. And then it just print out a new line. And here is the output of the entire program. The first three lines in the output shows the original content of S1, S2, and S3. And then it shows the result of calling the replace method on the string S1. Note that the result here is a new string that has the same content as the string S1, but with the two little l replaced with capital L's. And then it shows the result of calling two uppercase method on the S1 string object. And here the result is a new string with the content hello, but with all uppercase letters. And here is the result of calling two lowercase method on the string object S2. The result is a new string object that has the same content as the string S2, but with every letter replaced with the lowercase letter. Right? And here is the result of calling the trim method on the S3 string object. So the resulting string has the same content as the string S3, except that all of the spaces before and after the word spaces are removed. And finally, here is the characters in the char array variable after calling the method toCharArray on the S1 object. And so you see that these characters are the same as the characters in the string S1. The last string method we are learning in this video is the method valueOf. Note that every object in Java has a toString method to obtain the string representation of the object. But this doesn't work with primitive types because they do not have methods. Therefore, we need to use the string method valueOf that works with primitive types. The valueOf methods of class string, which are static methods, take an argument of any of these 8 types and convert it to a string object. There are 8 versions of method valueOf that takes one argument. Those 8 versions correspond to these 8 parameter types, including 6 primitive types and the char array type and the object type. There are also a version of method valueOf that takes 3 arguments, including a char array argument and 2 int arguments, namely offset and count. The 3 argument version returns the string representation of a specific subarray of the char array argument. Argument offset specifies the starting index from which the characters are used. argument count specifies the number of characters to be used. This version of method valueOf will throw an index out of bounds exception if the argument offset is negative, or the argument count is negative, or the sum of offset and count is larger than the length of the char array argument. Here is a program showing examples of using string method valueOf. In this program, it first declares 8 variables of the 8 data types that are accepted as the first argument of method's valueOf. Then the program calls method valueOf, passing each of these 8 variables as the first argument. Recall that valueOf is a static method of the class string. Therefore, it's called directly on the class string instead of a string object. So you don't have to declare any string object just to call the method valueOf. The first two calls of the valueOf method pass the char array variable, which is an array of time char, as the first argument. The call string.valueOf char array returns the string representation of char array, which is the string consisting of the characters in the char array. So it is showed in the output here. The second call uses the 3 argument version of the method valueOf with arguments char array 3 and 3. This call returns the string representation of the subarray of 3 characters starting from index 3 of char array. So the result is the string DEF. The call string.valueOf boolean value returns the string representation of variable boolean value, which has boolean value true. So this call returns string true. The call string.valueOf character value returns the string representation of variable character value, whose value is the character capital Z. Therefore, this call returns the string consisting of only character capital Z. The second part of the program includes method calls to the one argument version of the method valueOf using the remaining 5 variables as the argument. The value initialized to a variable long value has the L suffix, which indicates that it's a long value instead of an int value. Similarly, value 2.5 initialized to variable float value has the F suffix to indicate that this value 2.5 is a float value instead of a double value. However, the string representations of the long value and the float value do not include the suffixes. The string representations of the integer value, double value, or object def are the same as the strings displayed in those values. Here are more examples for you to practice with the string method valueOf. For these examples, you are supposed to tell what or print it out by the code, by the given code. Of course, you can type this code fragment into a complete Java program and run it, and you can see the output. But I like you to predict or to tell the output before you run it, and then you see whether it's correct or not. Okay. All right, so the first part is to print out the value of the Boolean variable b that is assigned to the condition 1 is larger than 2. Okay, so you should know what should be printed out by this println statement. That should be easy. Okay, and the second part is to print out the string s, where s is assigned to the string that is the representation of the number 1.2345. Okay, so we call the valueOf method passing this number, and it's supposed to return a value, and it returns a string value, and that string is assigned to the string variable s. And then we call the method to char array on the string s and assign the value to the returned value to the char array variable. So char array should consist of the elements that are from the string 1.2345. And then the last two println statements are to print out the valueOf method call with the 3-argument version. And in this calls, it uses the char array and passing 2 as the second argument. The last argument is either 4 or 5. Okay, recall that the last argument indicates the number of characters in the subarrays. Okay, and the second argument, which is also has a value 2 here, indicates the starting index of the subarray. So this call of valueOf returns the string representation of the subarray of char array consisting of 4 elements starting from index 2. So that could be 2, 3, 4, 5, right? How about the last one? And of course, for the last one, it wants to extract 5 characters starting from index 2 of char array. But that's not enough 5 elements starting from index 2, right? So what should be the result here? So the result here should be an exception, namely index out of bounds. Okay, so this one occurs because the offset plus the count, in this case is 7, is larger than the length of the char array. The char array has only length 6 in this case. We have learned a lot of string methods for processing strings, but since strings are made up of characters, we will learn class character, which is a predefined class for processing characters, and therefore is also useful for processing strings. Class character is one of the 8 type wrapper classes in Java. These type wrapper classes enable primitive type values to be treated as objects. In particular, class character enables values of type char to be treated as objects. Most methods in class character are static methods. designed for convenience in processing individual char values. Here is the list of some useful methods. Method is letter determines whether a character is a letter or not. Method is letter or digit determines whether a character is a letter or a digit. Method is lowercase determines whether a character is a lowercase letter. Method is uppercase determines whether a character is an uppercase letter. Method to uppercase converts a character to its uppercase equivalent, and method to lowercase converts a character to its lowercase equivalent. Each of these methods takes a single character as the argument and returns a Boolean value or a char value. Here's an example showing how to use the class character methods. This program asks the user to enter a character, storing the input into the char variable C. Then it calls the 6 methods of a class character listed in the previous slide, passing the variable C as the argument. It also displays the value returned by each method call. Here are 2 sample runs of this program. In the first sample run, the user enters character capital B, so the method call is letter of C returns true, and the method call is letter or digit of C also return the value true. The method call is lowercase of C returns false, and the method call is uppercase of C returns true. And the method call to uppercase of C returns also the capital B, okay? And the method call to lowercase of C returns the lowercase b. In the second sample run, the user enters character $. So all character methods is letter or digit, is lowercase, is uppercase, with C as the argument, return the value false. Method calls characters dot to uppercase of C and character dot to lowercase of C both returned the $, because it's not a letter. If you want to see more examples of the character methods, you can type in the code here into a complete Java program and see what is printed out by this code. Now we move on to class StringBuilder, which is another predefined class representing strings. Class string represents unmodifiable or immutable strings. String objects can't be changed once created. Class StringBuilder is used to create and manipulate dynamic string information, that is, modifiable string or mutable strings. Every StringBuilder object is capable of storing a number of characters specified by its capacity. If the capacity of a StringBuilder object is exceeded, the capacity expands to accommodate the additional characters. Of course, everything implemented with a class string can also be implemented with class StringBuilder and vice versa. Here are some performance tips for choosing between class string and class StringBuilder. Class string, not class StringBuilder, should be used if the data are not supposed to be changed. In programs that frequently perform string concatenation or other string modifications, it's often more efficient to implement the modifications with the class StringBuilder. Like class StringBuilder also have many constructors, providing many ways to create string builder objects. The first way is to invoke the string builder constructor without any argument. This invocation will create a string builder object with no characters in it and an initial capacity of 16 characters. The second way is to invoke the string builder constructor with an integer argument, such as 25. This invocation will create a string builder object with no characters in it and the initial capacity specified by the integer argument. The third way is to invoke the string constructor with a string argument, such as the string literal hello. This invocation will create a string builder object containing the characters in the string argument and the initial capacity equal 16 plus the length of the string argument. So the string builder object created by the call string builder hello has capacity equals 16 plus 5 because the string argument hello has length 5. Class StringBuilder has 4 methods to retrieve and modify its length and capacity. Method length returns the number of characters currently in the StringBuilder object. Method capacity returns the current capacity, which is the number of characters that can be stored in the StringBuilder object without allocating more memory. Method ensure capacity is a void method that guarantees that the StringBuilder object has at least the specified capacity, which is given as the argument of the ensure capacity method. Note that dynamically increasing a StringBuilder capacity can take a relatively long time. Executing a large number of these operations can degrade the performance of an application. If a StringBuilder object is going to increase greatly in size, possibly multiple times, then setting its capacity high at the beginning will increase performance. Method setLength modifies the length of the StringBuilder object. It's also a void method and takes one int argument, namely new length. If new length is less than the current length of the StringBuilder object, then the buffer is truncated to new length. If new length is larger than the current length of the StringBuilder object, then non-characters are appended until the total number of characters in the StringBuilder object equals new length. The null character is a character of ASCII code 0 and is not printable. Here is a program that shows an example of using the 4 StringBuilders method length capacity, set length, and ensure capacity. This program first declares and creates a string builder object named buffer from the string little hello, how are you? Then it prints out the string representation of buffer and its length and its capacity. Note that since a string builder object is not a string, you have to call its toString method to get the string content of the string builder object and pass it to the printf or println statement in order to print out its string content. The method toString of class stringBuilder returns the stringBuilder contents as a string. And here it calls the length method on buffer to display the length of buffer, which is 19, and it calls the capacity method on object buffer to display its capacity. So its current capacity is 35, which is equal to 19 plus 16. And then the program calls the ensure capacity method on the buffer object, passing 75 as the argument. So this method call will change the capacity of buffer from 35 to 95. And then the program calls the set length method on the buffer object, passing number 10 as the argument. This will shorten the length of buffer from 19 to 10. So that means that it cut off the string representation of buffer from 19 to 10 by removing 9 characters from the back or the end of the string representation of buffer. Here are more examples that serve as an exercise for you to practice with the string builder methods we have just discussed. In this exercise, you are given this Java code which creates a string builder object SB and calls method length, capacity, ensure capacity, set length, and toString on this object. It also displays the result. Your task is to tell what are printed out by this code. Alright, so I gave you 10 seconds to figure out your answer, and then you can come back to see the answer, the correct answer here. Okay, let's start the timer. Alright, 10 seconds have passed. Now you can see the correct answer, which is quite obvious. Okay, for the first one, it just displayed the length of SB. So the length would be equal to the number of characters in the string content of the object SB. So that is 3. So that could be 3. Okay. And for capacity, so the capacity should be equal to the current length the initial length plus 16. So it should be 19. Okay? And so now it calls the ensure capacity, and then it displays the capacity again. And so now note that here the capacity that is passed to the ensure capacity method is 18, which is less than 19. So let's see what is prints out. Okay, so now in this case, it still keep the current capacity because the new one is smaller than the current one. And then it called answer capacity method again, but now passing a number that is more than the current capacity. Okay, and now we see what is printed out. So it actually give it the capacity of 40. Okay, so there's some like a complex rule for how much capacity it could give when the given capacity is larger than the current one. Okay? The specified capacity is larger than the current one. Okay? So it's not always equal to the specified capacity. This one is just the mean capacity, the minimum capacity. Okay? And now it calls the set length and passing 5 as the argument. So note that the current length is 3, and now it expands the length to 5. So it needs to add 2 more characters. So now let's see what printed out here. So here it's still printed out high. Note that, but the string that is printed out here has 5 characters. The thing is that the last 2 characters are non-characters, which are non-printable. So therefore, you don't see it when it is printed out. But the string content that the object SB has after this set length method call would consist of 5 characters, including the 2 non-characters at the end. Class StringBuilder also has method chart and getChars that are similar to methods chart and getChars of class string. Method chart takes an int argument and returns the character in the StringBuilder object at the index specified in the argument. Method getChars copies characters from the StringBuilder object into a char array. It takes 4 arguments. The first argument is an int value indicating the starting index from which the characters should be copied. The second argument is the index 1 past the last character to be copied. The third argument is the char array into which the characters are to be copied. And the last argument is the starting index in the char array argument where the first character is placed. This program shows an example of using the StringBuilder methods chart and getChars. It first creates a StringBuilder object named buffer from the string literal hello there, all are in lowercase letter. Okay, and then it display the string content of buffer by calling buffer dot toString and pass it to the printf statement. So here's the output of the buffer toString, and then it also called the method chart with the argument 0, and then call chart again with the argument 4 on the buffer. So this displays the characters at index 0 and at index 4 of the current StringBuilder. The one at index 0 is the first element or the first character in the string hello there, so that is little h, and the one at index 4 is the little o. So because there are 4 letters before the O. Okay. And then it called the method getChars on buffer, passing 0 buffer length char array 0 as argument. So here char array is an array of time char that has the same length as the length of the buffer, the current length. Okay, and so then it displays the characters in the char array after calling getChars method on buffer. It uses an enhanced for loop to display all characters in a char array, and here is the result. It's exactly the same as the content of buffer. So here, because it tried to copy the entire array from index 0 and to the index equal to the length minus 1, okay? And the char array is the destination, and it stores the characters from index 0 of char array. Since class StringBuilder represents modifiable strings, it provides several methods that allow you to modify its string content. Two of those methods are setChared and delete. Method setChared takes an int argument and a char argument and sets the character in the StringBuilder object at the index specified by the int argument to the char argument. For example, suppose that we have declared and create the StringBuilder object named str from the string little hello there. And then we call str.chared passing argument 3 and capital T. Then this will set the characters at index 3 in the object str to the character capital T. So that means that it will change the little t to the capital T. So as a result, now when we print out the string content of str, it shows that the little t has been replaced with the capital T. Method delete takes two arguments of time int, and here we name them s and t. This method removes characters from index s to index t-1 in the StringBuilder object. For example, suppose that the StringBuilder object str has been created from the string little hello, and then we call str.delete 1, 3. This call to the method delete will remove the characters from index 1 to index 3-1, which is 2. Okay. So now we print out the content of str after deleting, and the result is hello, because the two characters at index 1 and 2, which are little e and little l, all removed by this call to the method delete. The principal operations on a StringBuilder object are the append and insert methods, which are overloaded with many versions so as to accept data of any type. Each method effectively converts a given datum to a string and then appends or inserts the characters of that string to the StringBuilder object. The append method always adds these characters at the end of the StringBuilder object. The insert method adds the characters at a specific point of the StringBuilder object. The compiler can use StringBuilder and the append methods to implement the plus and the plus equal string concatenation operator. Versions of methods append and versions of method inserts are provided for each of the primitive types and the char arrays and string and object and more. You can see the description of all those versions as well as other methods in the StringBuilder class at the following link to a document on oracle.com. Here's more examples for you to practice with the StringBuilder methods: chart, getChars, setChart, append, and toString. For this practice, you're supposed to tell me what are printed out by this given code, which starts with creating a StringBuilder object named SB from the string little hi. And now I also give you 10 seconds to figure out your answers and then come back to see the correct answers here. So let me start the timer. Alright, so I hope that you have figured out your answers. So now let's look at the correct answers. The first one is the printout of sb.char2. So that's supposed to be the character at index 2 of the StringBuilder SB. So it's supposed to be the exclamation point. Okay. For the next one, it's supposed to print out the value of char array after the call getChars, passing arguments 0 to char array 1. Okay, so recall that the second argument of method getChars is the index 1 past the characters to be copied. So in this method call to method getChars, it copies characters from index 0 to index 1 of StringBuilder SB because 1 equals 2 minus 1. Hence, the characters to be copied are capital H and little y. The last argument, which is 1, specifies that the characters are copied into char array starting at index 1. So the elements at index 1 and index 2 of a char array will be overridden with characters capital H and little I. So the result is A and then H, I, and then DE. So DE are the two remaining characters of char arrays that are untouched by the getChars method. And the last, the one next to the last one is the string. The string content of SB after calling setChart and an append method like this one. So the setChart will set the characters at index 2 to be a comma, okay, and then the append method appends the string starting with a space and then there to the string SB. So the result should be hi, comma, and then there. So there's a space between the comma and there. And the last one calls chart at the index 10. Okay, so note that here after appending the string there to SB, so it has, so how many characters does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 characters. So therefore, when you try to access characters at index 10, it should be out of bounds. So you could see the exception named string index out of bounds exception. Okay. Alright, so that's the end of this video. Thank you for watching, and I hope that you have watched all of my videos about programming in Java. And I also wish that you like Java programming. Happy studying.